Have you ever wondered what it would be like to live on other planets and not just Mars? Well, in that case, today's video is going to be your most favorite because we're going to unveil what living on other planets looks like and if a visit there is possible. So stay tuned and stick to the end. Subscribe to the channel for more fun videos every week. Our exploration of Mars will soon reach new heights thanks to the launch of more than 45 missions to Mars up till now, including a new NASA rover called Perseverance that will seek for indications of life. And there are legitimate reasons to be infatuated with it. Aside from the Moon, Mars is the only extraterrestrial place that humans could possibly reach within a generation. If we wish to travel to other worlds, Mars is a feasible option. It's also logical from a scientific standpoint. According to Suniti Karunatillake, a planetary scientist at Louisiana State University, it's the only other rocky planet in the solar system that has evidence for most of the key geological processes found on Earth today, such as volcanoes, sedimentary rock formations, and water-based polar ice caps. But it's possible that our fascination is driving us to overlook the rest of our solar system. Mars enthusiasm tends to create a feedback loop in which more resources are allocated to investigating the planet, which leads to fresh discoveries that pique interest, which leads to more public and private sector funding for Mars exploration, and so on. Sure, Mars is vital to study, but there are numerous strong reasons to begin expanding research for other nearby worlds. From the closest to the furthest, here are 5 potential locations worth investigating further. Venus. Venus serves as a warning about what might have happened to Earth if events had gone differently. The size, mass, and geological makeup of the planets are comparable. They appear to have comparable geological histories as well, particularly in terms of volcanic activity. Some data suggest Venus still has active volcanoes. Venus, like Mars, appears to have followed a similar growth and evolution route to ours. Today, though, Venus has one of the densest atmospheres of any planet we've ever observed, with a carbon dioxide content of more than 96%. On Earth, the pressure at the surface is similar to being 3,000 feet underwater. The temperature on the Earth is 464 degrees Celsius, which is hotter than Mercury. Greenhouse gases have run amok and rendered it completely uninhabitable, possibly a foreshadowing of what Earth might look like in the not-too-distant future. Because Venus is difficult to observe, it is shrouded in mystery. The surface is shrouded in sulfuric acid clouds, and the high heat and pressure kill most electronics and landing gear in a matter of minutes. As a result, one of the only ways we've been able to investigate the surface has been through radar. The last notable mission to successfully explore Venus in detail was the ESA's Venus Express mission, which launched in 2005, and the Soviet Union's Vega missions, which launched in 1985, were the last big landers dispatched to Venus. For this reason, the literature is comparably less detailed compared to Mars, says Karunatillake. It's prevented scientists from studying the planet in depth and mentoring future generations to continue along the same investigations. Europa. Let's be honest, Europa, Jupiter's 4th largest moon, is perhaps the finest site in the solar system to seek alien life. Europa is expected to have a subterranean ocean of liquid water that is kept warm by tidal forces, and while it would still be a harsh world, it could support life in the same way as hydrothermal vents deep under Earth's oceans do. Clay-like materials, which are commonly associated with organic remains on Earth, have been discovered on Europa, raising the prospect of detecting ongoing biological activity on the Jovian moon. We've been waiting a long time to pay a visit. We've had a lot of flybys from passing spacecraft, and the Galileo space probe, which orbited Jupiter from 1995 to 2003, gave us a lot of observation from afar. However, with so many new discoveries highlighting Europa's astrobiological potential, a mission dedicated to researching it is more crucial than ever. Titan. Titan, Saturn's largest moon and the solar system's 2nd largest moon, is the runner-up to Europa in terms of interesting moons. It's the only moon in the solar system with a strong, nitrogen-rich atmosphere similar to Earth's, and the only site in the solar system where clear evidence of lakes has been found. On Titan, however, these lakes are formed of methane, not water. It's feasible that primitive life may flourish in these conditions just as it would in bodies of liquid water. Inhaling hydrogen rather than oxygen, metabolizing it using acetylene rather than glucose, and exhaling methane rather than carbon dioxide would be required. Scientists also believe that Titan's atmosphere has aided the production of organic compounds, giving optimism for life another boost. However, we've never been able to determine how habitable Titan is or whether it contains any additional organic chemicals that could aid life's evolution. The Cassini probe, which spent 13 years studying the Saturnian system, provided some of our greatest Titan data. The Huygens lander, which gathered information from Titan's atmosphere and surface before going offline just 90 minutes after touchdown, was part of that mission. NASA is developing a new mission named Dragonfly for 2026, which will send a rotorcraft drone over Titan to examine the moon's potential for life in greater detail. Ceres. Ceres is a world where nothing is as it seems. It's the solar system's largest asteroid, so big that it's classified as a dwarf planet. Despite the fact that it is an asteroid, its geology is fascinating and diversified. It has a 30% ice crust that could be home to a salty subsurface ocean or numerous. It has a weak atmosphere formed by sunlight-exposed water vapor, and it contains cryovolcanoes or ice volcanoes that spit out water ice and salts. When you consider the abundance of organic substances, the possibility that Ceres was previously habitable or is currently habitable doesn't seem so far-fetched. Pluto. With a surface made up of 98% frozen nitrogen and mountains composed of water ice, the planet that became a dwarf planet is essentially an ice ball. Despite this, a 2015 visit by NASA's New Horizons mission reveals it's one of the solar system's most eccentric and unexpectedly active worlds. It has a wide range of colors, from frosty white to charcoal black to deep red, and is hotter on the inside than predicted, possibly indicating that it supports a subsurface ocean of liquid water beneath the crust. It has a thin atmosphere with methane in it, and data indicates that some organic compounds were discovered on the surface. While actual life on Pluto is extremely unlikely, the availability of the necessary elements for life is amazing. While studying Pluto, we can get a sense of what goes on in the Kuiper Belt and how it's able to produce these geologically active bodies that are so small and distant from the Sun, but still have enough internal energy to drive these processes, says Karunatillake. Pluto could be a sign that just because a planet is far away from the Sun doesn't imply it's dead. It's likely that we'll have to wait another decade before NASA or another organization decides it's time to send another spacecraft to Pluto or any other space body.